Good morning, Alex here. And if you are here, it's probably because you want to set up your database IDs in the best way possible. There's a lot of content out there. Even Blonde Theo did a video on this about a year ago, which UUID version to use. At the time, there was also CUID that was popular. He also walked through this great PlanetScale article that breaks it down even more. And there's a few tips in there that we'll be looking at today when we set up our IDs. But ultimately, how do we actually create some nice IDs? I have here a little project set up with Drizzle, and look at these pretty IDs. You have the nice prefix, kind of like Stripe does, and then you have this ID. But what is that? How can we make that performant? How can we avoid collisions with some randomness? What do we use to get that? Well, you're in the right place. We're going to break all of that down, and we're going to look at setting up IDs that do all of that, right? They'll probably need to be sortable because we want the performance. We want them to be exposable publicly. That could be in URLs. That could be anywhere you want to use your IDs. But then at the end of the day, we want them to be pretty and Stripe-like as well. So let's dive in. The first point here, which is avoiding collisions. And that's because IDs are used as typically primary keys on your database. And in the old world, that might have been some sort of serial or auto increment, right? Which provides assurance that there won't be any collisions. More recently, still in the old world though, you would have had UUID v4, which is a unique identifier that is fully random, right? So that ensures that there's no collisions, being fully random. And a lot of the other solutions, such as snowflake IDs, are also inclusive of a lot of randomness to avoid collisions, especially in serverless worlds and things like that. However, a lot of these ideas aren't ideal for the other points below. So obviously, serial and auto increment are going to be the most performant on your database. They're sorted by default, and this is what PlanetScale recommends for your IDs. When you go for something fully random, such as UUID v4 or some of the different IDs that Theo mentions, the CUID, the Nano ID, even CUID v2, they don't have this sortable aspects, which ultimately makes them less performant when used in the database. The database will have to rebalance the indexes and the trees as new entries are inserted, and that can lead to performance issues at scale. There's some debate around that, but most people agree that you should have sortable IDs for your primary keys to ensure optimal database performance. This requirement alone disqualifies UUID v4 from being used as our ID. And the reason for that is because it's fully random. So it won't be sortable and it won't have the database performance that we're looking for. We still have serial and auto increment that are good candidates. And before we go further, I'll mention that we now have UUID v7, which is now a standard spec that we can use. And the difference with v7 versus v4 is it includes a timestamp component in it. So whenever you create the UUID, the part at the beginning is the timestamp. So all new IDs as they're being created are sorted. V7 also includes a random part at the end, so it still helps with the collision avoidance that we need in order to use UUID v7 as a primary key. There are other versions with timestamps in them, but if you watch Theo's video, you'll know why v7 is a better handling of timestamps than the others. Now, the next requirement for our ID is, can we expose them publicly in our applications? So that could mean in a URL, that could mean somewhere in the page that's copy pastable. Well, now we're starting to eliminate a few more of these previous options. Obviously, a serial and an auto increment is not something we want our users to see publicly, because then they can even guess the next one in the series. They can just try a bunch of things in the URL, and maybe they'll even see data they're not supposed to. So serial, auto increment cannot be used publicly. UUIDs could be used and exposed publicly, including v4, which is why it was a popular choice in the past. But if you're using a sortable UUID or any of the other sortable IDs, that could be KSUID, ULUID, all the different sortable unique IDs out there, you might be exposing the timestamp component to your users. This means that if you have a v7 ID shown to your users, they could figure out when the record of that ID was created. Maybe that's not a problem for your use case, but ideally our IDs do not expose any of metadata associated with the records themselves. So it seems like no ID qualifies up till this point. V4 would be good to expose publicly, does not include any timestamp component, but we've already eliminated it due to the sortable and performance requirement. I'll show a little trick in a second to solve this problem. The last requirement I have here, and this is mostly aesthetics, is I like my IDs to look stripe-like. And what that means is it has a prefix, it has some nice character set that it uses, and this is mostly solved by encoding our IDs before showing them publicly. You may think base 64 is what you can use for that, but that still has some slash and dash characters. So a more commonly used encoding is base 58. This is what Stripe uses. This is what Bitcoin addresses use. And it's essentially base 64 with a few characters removed for better readability. You can also choose different bases if you want your IDs to be all caps or be all lowercase. This is really up to you and the look and feel that you're looking for. All right, so what's the conclusion here? What do we use? How can we get these nice, pretty IDs that meet all of these criteria? Well, let's jump into the code and have a look. I scaffolded a very simple Next.js project here using Drizzle. And if you look at my schema, it's very simple. It's just a table of IDs with a single column, which is using this resource ID custom type that I've created. Now, the secret on how we can make the IDs pretty externally, but performant internally, is actually using Drizzle's custom types. And if I jump into that, you'll notice it's using the custom type helper from Drizzle that allows you to specify how to get the value from the driver and how to push a value to the driver. And so we'll see how we'll implement this encode ID and decode ID so we can have a different ID in the database from what is shown in the UI and in your application, all the while having a great developer experience that you don't really need to worry about the internals of how things are stored. You always deal with the pretty IDs as a developer as well. So let's break this down. What we're taking in is a prefix and an optional database name for the column if we want to overwrite. So this is the same as you would typically have with Drizzle. But the important part of the custom type is the typing that we're doing here. I want the data to be prefixed. So I'm using template literal strings for that, where I will be putting the prefix type in front of ultimately the string that's going to represent our ID. And then following the recommendations from PlanetScale, if we want to use a UUID in our database, well, we better make it a binary type. So we save on space and make it as efficient as possible. So this is what I have here, where the data type of this column, ultimately when it gets stored, even if we're going to be using UUID v7, ultimately is just a binary encoded version of that UUID. The other thing I like to do is I like it to be optional to specify an ID when I'm going to be inserting a record. So I'm applying a default function on my custom type that's just going to generate a resource ID using some of the utilities that we're going to be looking at in a second. All right, so I know what you're thinking. If we're using v7 here, we're going to have the timestamp component in the ID. So encoding it, even if we use base 58 or some other base, it's still going to have the timestamp in there and people can figure it out, right? You can decode, figure out the base, and get the timestamp information. Well, this is where the little tip I have for you comes into play. We're actually adding an extra layer of encryption prior to doing the base 58 encoding. This makes it so the timestamp component of your ID is completely obfuscated away by the encryption. Now, there's two things that this introduces. One of them is now you have some secret key that's going to be your key for encrypting those IDs. And second, you may be thinking, well, doesn't this make it less performant? Now, every time I want to look at an ID or create a new ID, I need to also encrypt it. Well, lucky for us, all of these functions that do the encryption are extremely fast. Generating 500 IDs or looking at 500 IDs is insignificant compared to the IO from just querying the database. So this does not add any considerable latency to interacting with your database. Depending on how secure you want these IDs to be, you could just have your own made up key, which would be resource ID and then the prefix. I like to add an environment variable on top of that. Just note that if your timestamps and the metadata associated with the creation of those IDs is very sensitive, this key should not leak. Because if it leaks, you'll have to roll it. And if you roll it, that means all of your past IDs don't work unless you have some sort of mechanism for testing multiple keys. All right, so now that we know the secret, well, these two functions to put in our Drizzle type are very simple. Decoding means we get the external ID, which is the prefixed ID. We parse the base 58 payload off of that, so we remove the prefix and the underscore. We decode that so we get the raw binary data, and then we can pass it to our encryption to decrypt it and then ultimately resolve it to what needs to be put into the database. When we're encoding it, we're essentially doing the same thing in reverse. We're getting the raw binary data from the database driver, we're encrypting it, and then we're using base 58 to encode it, appending the prefix in front so that we get this pretty ID. Generating a new ID is also very similar. We're just adding this extra step up front to call v7 to get a new random ID that has a timestamp component into it. Then we're encoding that with what we just looked at. So like I showed, all of that comes together into this Drizzle custom type, encoding, decoding, and generating new IDs on demand. This is really how I like to generate every ID in my database. That way I have them look pretty, they're URL safe, they're encrypted, so you can't even deduct the timestamp from decoding them. And overall, they just look pretty. If you're using Drizzle with that custom type and the prefix type that I showed, you actually get an enhanced type safety developer experience because all of your IDs won't just be strings, they'll be prefixed with that template literal type that ensures when you're passing IDs around that they correspond to the specific database table or resource that you're querying. That's all I have for you today. If you found this helpful, hit a like and subscribe, and all the code that I showed will be linked in the description. Thank you for watching, and I'll see you again soon.